Now, when I speak about taking a Juniper router and connecting it to some Juniper switches, and also taking that router and connecting it to the internet, we know that there are indeed connections that make this happen. And two of the popular styles of connections that we deal with today in networking are Ethernet connections. These are typically into the local area network. Notice I said typically because there are certainly exceptions. And then optical network connections, oftentimes for wide area networking connectivity. Let's dissect some key ingredients of Ethernet and optical networks in this particular nugget. Ethernet is a layer 2 connection technology. We know it's the star of the local area network. Wait a minute here. I'm connected to a local area network as I deliver this training to you. So let me fire up Wireshark. By the way, if you're interested in training on the wonderful Wireshark, we have it here for you at CBT Nuggets. So let me fire this thing up and let me say, let's capture some traffic over my local area network connection. And I'm going to go ahead and start. So we can see that we are indeed capturing traffic. Let's go in and stop this capture and let's take a look at the information that we've collected. In fact, I notice something right here. Sure enough, my machine did an ARP, an address resolution protocol. Notice broadcast. I'm going to double click this and we can scrutinize that particular frame that we captured. Now, remember when we discussed the OSI model? I said the OSI model at each layer is going to encapsulate information. One of the things that's so cool about Wireshark is we get to see the information that is indeed encapsulated onto the particular data. In this case, our simple little ARP frame, notice we have an Ethernet 2 type of information that's encapsulated, so there's some fields that are put here. I want you to know these fields of an Ethernet frame. One of them is the destination MAC address. In a nugget on layer 2 addressing that I'll complete for you, I'll give you a tremendous information about a MAC address. But for right now, we can see one, and we see it's a very important one. It's all Fs, F as in Frank, and the all Fs is indeed one of these broadcast frames that we've been talking about. There is a source MAC address that is obviously not a broadcast address. It's the specific address of my network interface card that sent out this broadcast. Notice another field that we have in the Ethernet frame is a type field. This type is in hex and it's 0806, and sure enough, that means it is an ARP frame. Pretty cool. Let's grab another frame that we captured here. Here's a TCP packet that we captured. How cool. So if we look inside this particular packet, we see that sure enough, there's Ethernet 2 information that's been encapsulated on top of it, but there's also IP and TCP information. Notice, as we move up the OSI stack, we get more and more information encapsulated, as we said to you. So sure enough, in the transmission control protocol area, there's a source port value and a destination port value and a sequence number and an acknowledgement. Well, we went way farther up the stack than we care about right now, though. We want the Ethernet information. There's a destination-specific MAC address in this case, a source-specific MAC address. It looks like I have a Western Digital NAS device connected to my network, and I sure do. We notice there is the type of particular Ethernet frame that we're dealing with, and this time it's 0800. It's not an ARP frame, it's an IP frame. And we can notice there is some padding that has been added to this particular frame. So we have such a beautiful simplicity, don't we, when it comes to our Ethernet frame? Certainly not the complexity that we have as we move up the OSI stack. We know there's our destination MAC address. We know there's our source MAC address. We know there's a type field, the data itself. And one thing I want you to be aware of, not shown by Wireshark to us there, but there is a frame check sequence, a cyclical redundancy check to make sure that all of this information has indeed been encapsulated correctly. And of course, what's worth noting about Ethernet is the evolving that it's gone through. We lump Ethernet under IEEE 802.3 standards, and notice we just keep getting new variations. Every year it seems like there's an exciting new development with Ethernet technology. Now, great news, I don't have flashcards for you on all these because I would never want to memorize all this stuff. We just need to understand that a lot has indeed changed. I mean, I remember in 1990, I was indeed working with 10 base T, which had an operating speed of 10 megabits per second over twisted pair. It's tough to find that anymore, isn't it? Because we have standards now that give us fast Ethernet, 100 megabit per second Ethernet speeds. And then there's, of course, gigabit Ethernet and 10 gig Ethernet and 40 gigabit per second Ethernet and 100 gigabit per second Ethernet. And what's really mind-boggling is the fact that it's not just the LAN anymore. We can utilize Ethernet connections to send traffic at high rates of speed over wide area network connections. So we have to be very careful when we discuss technologies like Ethernet because it's no longer pigeonholed to the LAN. Now, for a good long time, Ethernet was all about copper. But there are fiber optic options when it comes to transmitting the data that our networks thrive on today, and we've seen generations of that technology occurring. 2 generations that we're responsible for at this level of our Juniper certification is SONET SDH and OTN. SONET stands for Synchronous Optical Networking, and SDH stands for Synchronous Digital Hierarchy. These technologies were originally developed in order to carry things like voice traffic. And then it was realized, wow, we can carry data in cells with ATM. And then, of course, SONET and SDH started carrying good old Ethernet frames. So there's been a real revolution in just that one category of technologies. OTN stands for Optical Transport Network, and it's carrying things like Ethernet traffic these days. Now, there are other technologies that predates SONET, but these are the 2 categories that I want you investigating for purposes of our certification level. I am including great PDFs for you on both of these subjects in your Nugget Lab files if you want to go further than our discussion here. When you look at SONET and SDH, you see different levels of bandwidth available. Like OC1 is a relatively low bandwidth option compared to OC12. With optical transport networking, we have OTU1, for example, OTU2. OTU2 allows 10 gigabit per second Ethernet over the fiber optic network. So we're no longer talking slow speeds here, just like we are in the Ethernet world itself. We're just seeing these amazing speeds that are possible. There is a huge distinction between these 2 technologies that I want you to be aware of. In the case of SONET and SDH, there is a multiplexing that takes place. Let me see if I can spell that. Yes, I can. It's so tough for me to spell and talk at the same time. But anyways, so we have multiplexing. What does multiplexing mean? Anytime we say multiplexing, we're talking about taking multiple conversations or data streams and sending them over the same pipe. In this case, the pipe is, of course, the fiber optic strands that we're dealing with. In the case of Sonnet and SDH, the multiplexing that is used is called time division multiplexing. What this is just what it sounds like. Different conversations, different carrier signals are going to be able to use the media, but at different time slots. Sounds a little inefficient, doesn't it? You know, this particular time slot, okay, you can go. Now stop, you can't go any longer. Okay, you can go again. So time division multiplexing is one way to get these different signals on the particular media. OTN uses a different approach. It uses wavelength division multiplexing. So with wavelength division multiplexing, the different signals are using different wavelengths in the potential spectrum in order to utilize that media at the same time. You may have heard that there's a coarse version and then there's a dense version of this WDM, or wavelength division multiplexing. We don't really need to get into the differences between these two. I just want you aware that there are those varieties in this approach to getting different signals on the physical media. Now, certainly one of the things that can overwhelm us in this discussion is all of the various technologies that are possible. We've talked about all these varieties of Ethernet that have existed throughout the years, all of these varieties in optical networking that have existed, and how Juniper and other network manufacturers respond is by having swappable interfaces that you can utilize inside their devices. Transceivers, they're called, that you can utilize. So here we see a list of supported Ethernet standards. So these are interfaces that we can swap out as we need to utilize different technologies. I'm scrolling through the list of Ethernet. Look at this. Massive list. And then we get to optical. So now we hit the supported Sonnet standards and we see the transceivers that are available. Notice it's listing here the specific model number, the transceiver type. SFP stands for small form factor pluggable. So our small little interface that we plug into on the device is indeed swappable. And we can see a bunch of different transceivers for the Sonnet. So it's great that we have this flexibility when it comes to the physical hardware of the device, because we may purchase a device and then down the road need to swap out those interfaces to support some new LAN or WAN standard that we really need to feature in our particular network. If you should want to go deeper with your exploration of these important topics, as I said, I've got PDFs for you that you want to check out in your Nugget Lab files. Also, when it comes to Ethernet, there is a specific nugget you might be interested in. If you go into your Nugget courses and you find Cisco's CCNA Data Center 640-911 DCICN, how's that for a title? The world we live in, right? If you find this particular title, if you pull this up, you'll notice I have a 30-minute nugget on a brief history of Ethernet. So this would really be something I think you would be interested in if you don't have the experience levels that many of your peers might have when it comes to this rather ubiquitous technology of Ethernet. Check that out in addition to the PDFs that I provide for you if you're interested. In this nugget, we explored Ethernet and optical networks, and we're not done by any stretch. Ethernet technologies like the MAC addressing and the address resolution protocol, so much of what we touched upon in this nugget, we're going to hit on again and again as we move together through this Juniper training. I sure hope this particular nugget was informative for you, though, and I'd like to thank you for viewing.